Today I'm gonna talk about odd, even, and neither functions. So even functions. Even functions are defined as the functions that have symmetry in the y-axis. The y-axis is the graph that runs vertically through 0. So this line over here in the graph is what we call the y-axis. And it's this line that's going to be the symmetry in the functions that we call even. Symmetry is when a shape looks identical to its original shape after being flipped or turned. Symmetry will be like a mirror image. Therefore, the y-axis is the symmetry in this parabola. Take a look. So the y-axis here is going to be our symmetry. It is going to work as a mirror. So as it is a mirror, this part over here will have to be exactly the same as this part over here. And we can see that it is indeed the same. This is identical to this graph. Algebra. As even functions have symmetry over the y-axis, a y value will have two solutions. One solution will be x, and the other solution will be negative x. This happens because they are located in different quadrants. So here we can see that this value of y will have two solutions. One which is going to be x, and one which is going to be negative x. So it will give us 2 points, negative x and y, and x and y. So all even functions will be just like that, and it will have to meet this requirement here. F of x will have to be equal to f of negative x. And here we can see that it does meet because f of x is the same as f of negative x. How do you know if a function is even? Here's an example to check if equation is even or not. We use these equations to help us understand, which is negative 3x squared plus 4. The first thing we'll do is write one equation using x and another using negative x. The one using x will give us the same, and the one using negative x will give us negative 3 times negative x squared plus 4, which will give us negative 3x squared plus 4. Second step to verify if the two equations are equal. So we can clearly see that this equation over here, f of x, is equal to this equation here, f of negative x. The third step is optional, but I really recommend on doing so we can check if our work is really correct, which is plugging in numbers to check our work. I chose to plug in 2 and negative 2. The numbers must be equal but with opposite sides. So x equals 2. It will give us negative 3 times x squared plus 4, negative 3 times 4 plus 4, negative 12 plus 4, which will give us negative 8. And with negative 2, negative 3 times negative 2 squared plus 4, negative 3 times 4 plus 4, negative 12 plus 4, which will also give us negative 8. So notice that they gave us the same solutions. So f of x, f of 2, is indeed the same as f of negative x, f of negative 2. So because negative 8 is equal to negative 8, we're sure that the function is even, as it meets a requirement of f of x equals f of negative x. To be even more clear, here's the graph of this function. So this is the graph of the function we just solved, and we can see that this is our symmetry, because this part is exactly the same as this part. So it is indeed an even function. So the graph is a parabola, and we can see that it's an even function as the y-axis is the mirror. That means the symmetry. Odd functions. Odd functions are defined as the functions that have symmetry in the origin. Origin is the starting point from which all other points are measured. It is the point 0, 0 in the graph. This point over here is what we call the origin, and is this point that is going to be our symmetry now in odd functions. The y-axis will not be our symmetry anymore, only in even functions. As the origin is the symmetry in odd functions, the origin will work as a mirror. We can also think as the half of the graph on one side of the y-axis is the upside down version of the half of the graph on the other side of the y-axis. This is easier to think about because it's easier to see in the graph. We see that this part over here is exactly the same as this, but upside down. If we turn this part upside down, it will be like that, and it will be the same as this one. Algebra. Because odd functions have symmetry in the origin, the equation that we use a x value will be the opposite of the one we use a negative x value. So here we see that f of negative x is different from f of x. They have the same numbers, but the signs are opposite. So f of negative x won't be the same of f of x. It will be the opposite of f of x. So all odd functions will have to meet this requirement here, which is f of negative x will have to be the same as negative f of x. But how do you know if a function is odd? The process is basically the same, only the answers will have to be different. We use this equation here as an example, 2x to the power of 3 minus 4x. First, we'll write one equation using x and one using negative x. The one using x will give us the same, and the one using negative x will give us 2 times negative x to the power of 3 minus 4 times negative x, which will give us negative 2x to the power of 3 plus 4x. Second step is to verify if the two equations are the opposite from each other. So we'll have to see if this one is equal to the opposite of this one. So 2x to the power of 3 minus 4x has to be equal to negative times negative 2x to the power of 3 plus 4x. So 2x to the power of 3 minus 4x is indeed equal to 2x to the power of 3 minus 4x. So yes, they are the same. This one is equal to the opposite of this one. But to check our work, we have to plug in numbers. I will plug in 2 and negative 2. So when I plug in 2 times to the power of 3 minus 4 times 2 times 8 minus 8, 16 minus 8 gives us 8. And when we plug in negative 2 times negative 2 to the power of 3 minus 4 times negative 2. So f of negative 2 is 2 times negative 8 plus 8, which is negative 16 plus 8, which gives us negative 8. So we can see that they are the opposite. F of x, f of 2, is the opposite of f of negative 2, f of negative x. So 8 is the opposite of negative 8, so we are sure the function is odd because it meets the requirement of f of negative x equals to negative f of x. And to be even more clear, here's the graph of this function. So this is the graph, and we see that the y-axis is not our symmetry anymore. This part is not the same as this one, but the origin is, because this part, if we turn this upside down, it will be something like that, and it will be exactly the same as this side over here. So we are sure it is an odd function because on one side of the y is its other side but upside down, and we have symmetry in the origin. We also have neither function. A neither function will be a function that does not have symmetry. It will be neither an odd nor an even function. Here's a graph that illustrates that. So this graph, it represents a neither function because the y is, we don't have y-axis symmetry, because this side is not the same as this one, but we do not also have the origin symmetry because this side here is not the upside down side here. So notice that it does not have symmetry neither on the y-axis nor on the origin. Algebra. Sometimes the function will be neither odd nor even, therefore it will not meet neither f of x equals f of negative x, nor f of negative x equals negative f of x requirement. When a function is neither, they will not meet neither of those requirements. Here's an example. We will use this equation. 2x to the power of 3 minus 3x squared minus 4x plus 4. First, we have to write an equation with x and one with negative x. The one with x will be the same, and the one with negative x will be 2 times negative x to the power of 3 minus 3 times negative x squared minus 4 times negative x plus 4. It will give us negative 2x to the power of 3 minus 3x squared plus 4x plus 4. Second step to verify if there is a relation between the two equations. The two possible relations are f of x being equal to f of negative x, or f of x being the opposite of f of negative x. So let's see if f of x is the same of f of negative x. So here we see that they are not the same. So let's just cross out this relation because this will not work anymore for us. let's see if this relation works. So first, let's find the opposite of f of negative x. This is f of negative x. I just multiplied by -1, and it gave us this equation, which is the opposite of f of negative x. So f of x must be equal to the opposite of f of negative x. And we can see that they are not the same, they are different. So let's just check it one more time by plugging in numbers in our third step. So we'll plug in 2 and -2. When we plug in 2, it will give us 2 times 2 to the power of 3 minus 3 times 2 squared minus 4 times 2 plus 4 to give us 16 minus 12 minus 8 plus 4, which is 0. F of -2 is going to be 2 times -2 to the power of 3 minus 3 times -2 squared minus 4 times -2 plus 4 to give us -16 minus 12 plus 8 plus 4, which is going to be -16. We can see that they are completely different answers. They are neither the same and neither the opposite of each other. So as the function does not meet neither requirements, we can consider it a neither odd nor even function. And here's the graph to show that it is a neither function because it does not have y-axis symmetry. This side is not the same as this side, and it does not have origin symmetry because this side is not this side upside down. So the graph does not have symmetry, neither on the y-axis nor on the origin. Therefore, the function is neither odd nor even. So here I have a summary for you guys. So even functions, they have symmetry on the y-axis, and they must meet this requirement of f of x being the same as f of negative x. Odd functions, they have symmetry on the origin, and f of negative x must be equal to negative f of x. And neither functions, they have no symmetry, therefore they meet neither of those requirements. Thank you.